It's reactive, unrestrained, and electrifying. Meet the Ginetta G40 today on How It's Made Dream Cars. British automaker Ginetta and Team LNT are synonymous with racing, making headway in auto racing history for decades. Since its acquisition by Lawrence Automotive in 2005, it's expanded greatly. Ginetta released the G40, its first road car in 15 years. From the 1960s G10 and the Le Mans prototype to this 1964 G4 road and race car, an impressive history. Ginetta was founded in 1958 in Woodbridge, England, by the Wauchope brothers. In 1961, it introduced the G4, a road car and weekend racer. In 2005, Ginetta was acquired by LNT Automotive, rejuvenating the brand. The G40 road car differs from its racing counterpart by using an American engine, a Japanese-inspired gearbox, and a road-friendly interior. The G40's big advantage is simplicity and lack of driver aids like power steering, traction control, or ABS. Manufactured at the state-of-the-art factory located in Garforth, Leeds, the first G40 road car was drafted on paper, visualized through 3D computer rendering, and hit the road for testing in under a year. And below the stunning surface is a cold-drawn steel seamless tube chassis. At another location, a supplier produces and stores the pre-cut steel tubing for the chassis assembly. Two workers lift a tube into a 3D laser pipe-cutting CNC machine for precision clipping. This CNC machine can cut tubes with diameters from ½ an inch to 8.5 inches. Cutting is managed with an automatic loading and tilting system. Once a piece is cut, it's automatically unloaded onto a transition belt. Then the parts are collected for further machining. Back at the main factory within the chassis fabrication department, a machinist twists aluminum tubing to create the radiator's coolant pipe, a hard pipe which carries coolant from the engine block to the radiator. This portable benchtop tube and pipe bender functions with a single bending speed. This allows the pipe to be carefully fashioned to meet unique manufacturing specifications. Eventually, the car's internal chassis framework will consist of 262 segments of bent and straight laser-cut tubes. At a primary workstation, a technician places the rear roll hoop structure onto the chassis jig. It's positioned using a tape measure, along with a rubber mallet for key placement. Pieces are welded using a metal inert gas welding unit or MIG gun. At another workshop, a technician places a pre-cut plate of steel onto a traditional piece of equipment called a fly press. This manually presses and shapes the material into what is known as a gusset. The gussets are large brackets that connect and strengthen cross members of the chassis. Once a gusset is machined, the part is welded to the steel base frame with the MIG gun. Adding more of the laser-cut steel tubes, the welding technician snaps and locks the upper components into the chassis jig. Now he's building the box section, where areas like the passenger and driver side chassis tubes are aligned. Next, he moves on to weld, forming a larger solidified structure. In total, 103 tubes are installed to form the box section. The installation of the driver's side footwell and bulkhead are easily applied due to the 3D computer-aided design. Now positioned on a chassis roller, The preliminary space frame is rotated to different angles. This helps to finalize specific welds below and around the base of the frame. When finished, the chassis is electrostatically powder-coated black. The G40's inexpensive 1.8-liter American engine is the same engine block found in older versions of Ford's compact cars like the Focus, Escort, and Fiesta. This particular engine assembly starts with a technician installing the intake and exhaust camshaft cylindrical rods, which run the length of the cylinder bank. A friction-reducing camshaft assembly lubricant is then applied to ensure the part's operational demands. As part of the camshaft units, ball bearings are fastened at both ends of each bar. This will reduce rotational friction and support the cylindrical rods. Working with the cylinder bank to house the camshaft rods are 10 camshaft brackets and their fastening bolts. They help the camshaft units to remain in position for their proper synchronization with the crankshaft. Using an impact driver, each support clamp and fastening bolt is precisely installed. A designated amount of torque is applied in order to avoid any damage to the hardware. Using a specialized paint pen with blue ink, known as torque paint, each bolt is marked for quality assurance. Next, the technician attaches the camshaft sprockets, which are responsible for maintaining the timing between the camshaft and the crankshaft. To ensure the sprockets are exactly adjusted, a manual torque wrench is used to fasten the bolts. Again, torque paint is applied to mark if the part has been tampered with or becomes loose. The tensioner pulley and idler pulley regulate the system's timing belt. They are also adjusted, fastened, and finally marked with torque paint. Attached to 3 specific areas of the crankshaft sprocket are thick pieces of double-sided tape. They temporarily support a metallic precision cam degree wheel, which accurately sets the camshaft timing while also checking the valve timing. In this step of the engine building process, he is using a cam degreeing kit, which lets him check the piston to valve clearance with accuracy. It ensures that the engine valves are opening at the correct point in the piston cycle within the cylinders. Any error in the settings can cause the parts to malfunction, causing damage to the engine. Timing is also verified to ensure the crankshaft and camshafts are aligned. Next is the 4-cylinder exhaust manifold. It collects exhaust gases from different cylinders that are then sent through the catalytic converter to exit the rear exhaust pipe. The technician attaches the exhaust manifold with studs and nuts, using an impact driver for torque force precision. Coverage is added like the aluminum backing plate for the airbox. A plastic camshaft cover follows, along with the aluminum timing belt cover, the water pump pulley, and a plastic camshaft sprocket cover. The engine block is ready for the road and track. The G40's dashboard, transmission prop tunnel, and interior side trim are made of chopped strand matte fiberglass with a polyester resin and a gel coat finish. Looking stellar starts on the inside. Especially useful on new molds is a layer of mold release wax, which is formulated for the easy removal of a part from a template. Following the implementation of the release wax, a jet black gel coat of a high-quality resin finish is spread across the surface. Once the gel coat is applied, The mold is shuttered to another area for curing at room temperature. Gel coat will not cure adequately below 59 degrees Fahrenheit. And at temperatures above 86 degrees, it will cure too quickly. After the drying process, an epoxy emulsion is painted onto the surface. It is now ready to receive chopped strands of fiberglass that are mixed with more of the high-strength bonding glue. These strands are made by chopping continuous glass filaments coated with a chemical sizing into a specified length. These strands ensure the compatibility with the resin to reinforce the plastic-like structure and provide acoustical insulation. The workers apply several layers of continuous filament mats that provide rigidity, conformability, and tensile strength. The continuous filament mats are a non-woven mat made from fiberglass filaments. They consist of continuous fibers randomly oriented in multiple layers. The glass fiber is bonded with a silane coupling agent, and the layers are held together with a suitable binder. Finally, a small fiberglass resin roller consisting of thin parallel fins with deep grooves eliminates air on the flat surfaces and gradual curves before the part is cured. The impression of the transmission prop tunnel is separated from the mold using plastic wedges and subtle arm strength. If more force is required, workers use a whitehead rubber mallet to tap the mold. But the process doesn't end here. In a secure room, wearing protective gloves and a mask, the machinist removes any and all excess fibrous materials with an angle grinder to prepare the part for a proper smooth finish. Within the transmission prop tunnel is the open portion that is allocated to the gearbox, gear shifter, and parking brake components. Using a small reciprocating saw designed for microcutting, he plunges the hand tool into the panel, making accurate cuts along the perimeter. To follow up, the cut edges are shaped, smoothed, and finished. He exerts pressure to the fiberglass with an air sander and a belt sander for precision quality and ultimate cleanliness. At another work table, he treats the part's exterior with a polishing compound in order to create a cosmetically dynamic finish and surface shine. Altogether, this process removes any flash lines created when the shaping mold and finished component separated. He uses a variable speed polisher equipped with a wool polishing bonnet that rotates from 600 to 3,000 revolutions per minute. He conditions the surface of the part, giving it a high gloss finish and reflective impression. With an impact driver, the technician drills the component, creating the necessary holes for soon-to-be installed screws, bolts, and other fastenings. Control elements in the car's cockpit, like the gear shifter and parking brake, will be linked to the transmission prop tunnel. A leather trim will also work in tandem with these sections. The technician applies a polyurethane adhesive, which secures nut plates to the underside of the component. It allows the trim surrounding the gear stick to bolt on. This adhesive also allows for a little flexibility, never cracking over time due to vibrations. Bolts secure the nut plates during curing. Instrumental to the cockpit and the driver's satisfaction is the dashboard, which shares a number of characteristics with the G40's racing sibling. The overall panel, function buttons, and operations indicators translate perfectly onto this road car. Stunning styling and excellent performance are in every Ginetta car, from the electric G40 to this 1960s G10, to the G60 supercar, and the G40 is an undeniable addition. 70 staff members produce 300 cars a year, with each vehicle taking 4 weeks to build. Delivered using a hydraulic elevating cart, the first component in this step-by-step marriage of elements is the rear differential. It's designed to drive a pair of wheels while allowing them to rotate at different speeds. Next are the rear upper suspension wishbones, which control the vertical movement of the wheel throughout suspension travel. 2 half axles connect to the gearbox and differential on either side. This is a fuel cell bladder. It's a gasoline tank encased in a fabricated aluminum housing case and secured with metallic straps. Transmitting power from the gearbox to the differential is the one-piece universal joint called a torque tube, or better known as the drive shaft. More wiring and tubing is attached with twist-tail cable ties. This wiring is for the power of the in-tank fuel pump and the fuel hose that feeds to the engine's fuel rail. After most essentials are affixed to the chassis, cockpit components like the fiberglass rear bulkhead trim, which separates the cabin from the fuel tank and rear suspension units, get added. Following the addition of the rear underside is the side ceiling trim panel, which securely closes the cabin from the exterior. Using an air hydraulic rivet gun, the technician sets the mechanical fasteners into their proper locking positions. As the production of this car gets closer and closer to the finish line, workers deliver the main fiberglass body shell that snaps easily onto the chassis frame. The doors are mounted with conventional hinges. Next, the workers use an air hoist to drop in 2 of the most essential items: a completely frame-fitting engine and the gearbox assembly. In this work area, a technician slides a sheet of corrugated aluminum into a manual guillotine shear. Using the pneumatic foot pedal, this machine shears the sheet quickly with a heavy descending blade. After cutting, it's moved for bending to a counterbalance box and pan folder. The sheet is clamped into place, and a counterweight generates the force to bend the metal. Created using the box folder is the heat shield, which surrounds the catalytic converter, a vehicle emissions control device that reduces toxic pollutants and exhaust gas. The heat shield also protects the bulkhead, bodywork, and cabin from the high heat generated by the converter. Once the shield is installed, the technician can finally install the radiator's water pipe. Dressing the car's cockpit with road and race-worthy dynamics continues as the workers firmly install the jet black fiberglass transmission and prop shaft cover. Next is the addition of the minimalistic racing-inspired dashboard panel, with its very few metallic control buttons and operations instrumentation. More control is added with the steering column switch cluster, a gauge panel, and the racing-inspired steering wheel. Unlike most sports cars, the front bonnet is composed of the bumper, headlamps, fenders, and hood as a whole unit. This frontal kit snaps into place with the flick of the hood latches, clamps commonly used on race cars. The racing world has always been priority number 1 to the automaker. Even more so to the company's chairman, a former racing champion. The team always rolls with the truck equipped with a portable dynamometer, allowing testing from headquarters. The factory dyno verifies the engine power and drivetrain performance of new cars sold to customers, while the portable system preps team cars for race day. It's not essential to be a millionaire to get behind the wheel of this British, handcrafted street-legal race car. The G40 is designed with the budget-conscious, entry-level racing enthusiast in mind. And where it really thrives is at the track, like here at the world-renowned Silverstone circuit. With an automotive heritage formed by four brothers and rejuvenated by a company unlike any other, Ginetta has always been about racing's adrenaline-pumping discipline. As a pavement-hugging road car that flourishes on the track, yet affords inexpensive, dependable fun racing, the G40 is more than just a fantasy. It's a dream car that proves it.